Good evening, it's Rob with Sine Wave Specialties. It's been a while. One of the things we're going to go over today is dimensional analysis. Why is this important? Well, I have a Chegg subscription and a Course Hero subscription. One of the things that they messed up was actually doing dimensional analysis. They had areas and volumes messed up. Now, I'll show you what I mean. So what they had on one of their measurements was 60 centimeters squared equals how many meters squared? Well, what they ended up doing was saying that this was 0.60 meters squared. That ain't correct. That's like saying that, we'll say 100 meters cubed, well, we'll say just for sake of consistency, centimeters cubed equals 0.100 meters cubed. Or sorry, millimeters. There we go. That's not correct. That's not how you do it. Now I'll show you how you actually do it. Let me grab the eraser. This is how it's supposed to work. This isn't the proper way to teach it, but you know, it clarifies. So what we're going to do is we got a box. And one of the things we got right here is we got 3, 3, and 3. So we're going to find the volume of this, and we'll say all of these are centimeters. So when we do the math for this, what is our volume of this box, or this cube? We're going to say 3 centimeters times 3 centimeters times 3 centimeters. What's 3 times 3? 9 times 3, 27. Well, centimeters times centimeters times centimeters is centimeters cubed. But now we want to take this and we want to get meters cubed. Well, how do we do that? Well, let's do this the fractional conversion way. So we got 27 centimeters cubed. And we want to make that into meters. So 1, we put this over a 1 because it's a whole number. Now what we need to do is we need to do the conversion. Whatever is up here needs to go on the bottom all the way across. We have centimeters here. 1 centimeter is equal to 10 thousandths of a meter. This is how they did that 60 to 0.6. This is why it's wrong. If we cancel centimeters here and here, we're left with 27 centimeters squared, but now it's 0.27 centimeters squared meters. That doesn't make any sense. You can't have two different dimensions in the numerator of a problem. So what you have to do is you have to get this to cancel out, so you end up with meters cubed. You have 3 up here. This is your conversion amount. If you take this and put it on here as many times as the exponent has, you will get that in meters. So we already have 1. There's 2. There's 3. Now you can go 1, 2, and 3. Those cancel. And then you got meters cubed. Meters times meters cubed. So we have 27 centimeters cubed over, and this would be times 0.01 times 0.01 times 0.01. So now that we got all that, we can put this over 1 times 1 times 1 times 1 centimeters cubed. We can cancel this out. This is meters, meters, and meters. We can cancel that out and cancel this out. So we got a 1 right here with nothing on it, because this is gone. So now we got 2 decimal places, 4 decimal places, 6 decimal places. We're getting that from 1, 2, 1, 2, 1, 2. So we have our 7, we have our 2, 1, 2, 1, 2, 1, 2. That's kind of screwy. So we got 0.1, 2, 3, 4, 5, 6. meters cubed. That is what it should be. Now, do you see the difference? That's the issue. People don't understand how to do these conversions. So now, we're going to take that. We're going to do this one more time with an area. Got a box. It's 9 times 9, right? Just to make it look fancy, we'll go 12. Right, so we got a box. 9 times 12. Not that hard. What we end up getting, so the area equals 9 times 12, which runs out to 108. Right? Now, this is going to be, we'll say this is, we'll say it's millimeters. So we have millimeters 1 and 2 squared, right? Now, if you're not a total damn goofball, you'll understand that the 2 means that many conversions. Again, we're going to take this to, we'll say centimeters. We'll go from millimeters to centimeters. What is this in centimeters squared? Well, first of all, we got to take 108 millimeters squared. We need millimeters, millimeters again, just to balance this out. 1 millimeter, 0.1 centimeters, 0.1 centimeters. 2 of these, 2 conversions. Now we just got to multiply them out. End up with 108 times 0.1 times 0.1. We got 1 times 1 times 1, which comes out to 108. Move the decimal over 2 spots. 1.08. What are we going to? Centimeters squared over 1. So our answer is right here. That's how you get that one. That's how you get that one. That is how you do your conversions. And a lot of the time what they don't seem to understand is that up here. So if I want to go to, let's say, I'll try another one just for an off-the-wall concept, actually. So let's say you want to go from 1054 millimeters to the 5th, and you want to get meters to the 5th. How do you do it? Once again, the number up here matters. First, write out your original number. You have 5 up here, you need 5 down here. So, 1 millimeter, 1 millimeter, 1 millimeter, 1, and 1 more. Millimeter to meters is times 10 to the third, negative third. So we need 0.001, 0.001, 0.001, 0.001, and finally 0.001. And you have to multiply this out. 1, 2, 3, 4, 5. So we know we have our 5 to cancel this out right here. 1, 2, 3, 4, 5. That's gone. Up here, we have our meters. Now that we have our meters, we already know that we're going to get meters to the 5th. So 1054 is going to be 3, 6, 9, 12, 15. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Really small number. That millimeters cubed is going to be now meters to the fifth. That is how you do it. Because one conversion goes 3, 2, 3, 4, 5. 3, 3, 3, 3, 3. So, every time you do millimeter to meter, or sorry, wait, yes, okay. Because right here you have your 10 to the negative third, 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 and 10 to the negative third again. 1, 2, 3, 4, 5. This is your exponent. This is your conversion. This is your answer. That's how you get it. So when you come over here and you do these, you need to make sure that whatever your exponent is up here, when you do these conversions, remember, metric, you can't make this inches. You don't need another space shuttle accident in the stratosphere. What you need to do is you need to make sure that one, you know what it takes to get from one dimension to the next, or one dimension to the next. You need to take into consideration how many conversions you need to do. This, yes, it's your exponent, like 1 to the fifth is still 1 times 1 times whatever. But you need to do it that many times for that conversion. It's just like if you had 10 to the first meters to 10 kilometers, or 10 to the negative third kilometers. You have to do it 10 times 10 to the negative third. It's 1 time. You don't have to do this many times because the exponent's not a 5. And it's not a 4 like we did earlier. It's not a 3 like we did earlier. It's just the 1. So once you do that, you get 0.1. And that's your kilometers. So make sure when you do this, you get that exponent, and you go into something else, saying chemistry, physics, the area problems in calculus, technical physics, some stuff in statics, not much. But yeah, this is how you do it. Hopefully this helps. This has been a small rant for the people I'm paying $14 a month, even though somehow they got the right answer at the end. They still did the conversion wrong. But hey, that's why they don't pay me to do it, right? Huh?